On the death anniversary of Satyendra Nath Bose, the man behind Higgs boson, or the God particle, we revisit how Einstein stepped in to save his rejected paper, leading to the Bose-Einstein Statistics. Though Bose never won a Nobel, his work helped shape the field of quantum physics. On a typical day in 1924, Satyendra Nath Bose, a physicist from Kolkata, faced a disappointing setback. His paper on quantum statistics that introduced a novel way to describe particles of light, photons, had been rejected by a prominent journal. His paper treating particles as indistinguishable, challenging classical physics. It was a brand new concept, perhaps too bold for the time, and the philosophical magazine rejected it. But Bose decided to get bolder. He sent his work directly to Albert Einstein. Einstein immediately recognized its importance. He not only translated it into German, but also submitted it to the prestigious Zeitschrift für Physik on Bose's behalf. This single act gave birth to Bose-Einstein Statistics, a fundamental principle in quantum mechanics. Eventually, Bose's insights led to the discovery of the Bose-Einstein Condensate, a new state of matter observed at extremely low temperatures. If Einstein hadn't stepped in, Bose's research might have been buried in obscurity. But thanks to their collaboration, his work laid the foundation for understanding an entire class of particles, bosons, which are named after him. On the death anniversary of Satyendra Nath Bose, we look back at the life of this humble scientist who never won a Nobel but changed the field of physics forever. Born on January 1, 1894 in Calcutta, now Kolkata, Satyendra Nath Bose had always been a bright student. He attended Hindu school and later Presidency College, where he consistently topped his class, even surpassing his classmate and future astrophysicist Meghnad Saha. Saha and Bose also co-authored several research papers early in their careers. He earned his BSc in mathematics in 1913 and MSc in 1915, both with top ranks. His teachers included renowned mathematician Jagadish Chandra Bose and physicist Prafulla Chandra Ray, who inspired him to aim high. He got married in 1914 to Ushabala Ghosh while he was still a student. While details about their personal life remain private, it's known that Ushabati was a supportive partner throughout Bose's academic journey. We know of the Higgs boson, often called the God particle, thanks to Bose's principles. Bosons are particles that mediate forces in the universe. The Higgs boson in particular plays a key role in the Higgs field, which gives particles mass. Without Bose-Einstein statistics, scientists would not have been able to predict or understand how bosons behave. Satyendra Nath Bose's work laid the foundation for these discoveries, even though he never worked directly on the Higgs mechanism. The standard model of particle physics, which explains fundamental forces in particles, is built on the statistical principles Bose pioneered. While he did not single-handedly transform quantum physics, a field rapidly evolving at the time thanks to Planck, Einstein, Schrödinger, Heisenberg, and others, his contributions were critical in shaping its development, especially in areas related to quantum gases, superconductivity, and the Higgs boson. Satyendra Nath Bose's brilliance was recognized in many ways, even if not by the Nobel Committee. In 1958, he was elected as a Fellow of the Royal Society FRS, one of the highest honors for a scientist. But unlike many of his contemporaries such as P.C. Mahalanobis and Homi Bhabha, Bose chose to remain in India, dedicating his life to research and education instead of seeking global fame. This humility defined him. Much like bosons, essential yet invisible until the right conditions reveal them, Bose's contributions, though immense, often remained unnoticed in the larger narrative of physics. Bose once remarked that the joy of discovery mattered more than recognition. True to his words, he never sought awards or titles, believing that his work was its own reward. He was also awarded the Padma Vibhushan by the Indian government in 1954. Unlike many theoretical physicists, Satyendra Nath Bose had an intuitive, almost poetic approach to science. He believed that understanding science should not be confined to elite academicians, but should be accessible to all. In 1921, Bose joined the University of Dhaka as a reader in the physics department. Here he established new departments and laboratories, teaching advanced courses and fostering a culture of research. Bose had a unique knack for simplifying complex scientific concepts. He used everyday examples to explain quantum mechanics, making sure his students understood even the most difficult concepts. This approach earned him deep respect among his students, many of whom went on to become pioneering scientists themselves. He encouraged hands-on learning, often designing equipment himself and urging students to use local materials. Satyendra Nath Bose passed away on February 4, 1974 in Kolkata. His legacy lives on, not just in the particles named after him, but in the countless students he inspired and the profound impact he had on quantum physics. Every physics student now learns about Bose-Einstein Statistics. Every time scientists discuss bosons, they honor his legacy. His work continues to shape quantum mechanics, from theoretical physics to practical applications like superconductors and quantum computing. Bose's story is a reminder that true genius isn't measured by awards, but by the knowledge that changes the world. And in that sense, his place in history is already secure.